You ever wonder what's really going on before that little update notification pops up on your screen? Well, it turns out there's this massive, hidden system working behind the scenes, fighting a constant battle against all sorts of invisible threats. So let's pull back the curtain and take a look at the secret life of a software flaw. 107. Just a number, right? Well, stick with me, because that number is the key to understanding the sheer scale of what we're talking about here. And boom, there it is, 107 security flaws. Not for a year, but for a single month, in just one update for one operating system. And you know what's crazy? This wasn't some huge emergency patch. It was just a regular old Monday for the team at Google. So, what does that actually mean for you and me? Well, for one, it means we're pretty much living in a constant tsunami of software updates. I know, it can feel like a total pain. But trust me, every single one of those notifications is a critical part of a massive global defense system. Okay, think of it like this. Every single piece of software we use has these tiny, invisible cracks. And you've got people on both sides, the good guys, the security researchers, and the bad guys, the hackers, who are constantly looking for them. As soon as a crack is found, it becomes this race against time for the software company to seal it up. And that seal, that's the patch that gets delivered to your device as an update. So, when you've got this global flood of flaws, how in the world do you even begin to manage it? You absolutely need a system, a way to identify every single threat, to track it, and to talk about it so that everyone's on the same page. Basically, you gotta give the enemy a name. And that's where something called a CVE comes in. It stands for Common Vulnerabilities and Exposures, and it's really just a standardized naming system. When a new flaw is found, doesn't matter where, could be anywhere in the world, it gets its own unique CVE number. This is huge because it means a researcher in Tokyo, a developer in Sao Paulo, and an engineer at Apple in California can all talk about the exact same problem without any confusion. All right, to make this less abstract, let's follow one specific flaw through the whole process. Our case study is CVE 2025-1101. Now, this was a vulnerability found in 7-Zip, which, is that super popular program that millions of us use for zip files and all that. Okay, so the technical jargon for this flaw is directory traversal, but you don't really need to worry about that. What you do need to know is the impact, and it's a scary one: remote code execution. Let me break that down. It means a hacker could run any program they want on your computer. All they'd have to do is trick you into opening a sneaky, specially made zip file. That's it. They wouldn't need your password, they wouldn't need to be on your network, they could do it from anywhere in the world. So you see, not all bugs are created equal. Once a flaw gets its CVE number, the very next question everyone asks is, okay, so how bad is it? I mean, a bug that just makes an app crash is annoying, for sure. But it's a whole different ballgame from a flaw that basically hands an attacker the keys to your entire digital life. And to measure that risk, there's another system called the CVSS, the Common Vulnerability Scoring System. The best way to think about it is like the Richter scale for earthquakes, but for cybersecurity threats. It gives every flaw a score from 0 to 10. This is absolutely crucial because it gives everyone a super quick, standard way to see how serious a flaw is and, more importantly, which ones need to be fixed, like right now. So, what about our 7-Zip flaw? It got a CVSS score of 7.8. On a scale of 10, that's solidly in the high-severity category. When developers and IT pros see a number like that, it's like a blaring alarm bell. It tells them, drop what you're doing, this is a big deal, and it needs to be fixed ASAP. To really get what that score means, let's look at the difference in impact. Our high-risk 7-Zip flaw, that's like leaving the front door of your house wide open. An attacker can just walk right in from the outside. But a medium-risk flaw is a bit different. It's more like the attacker's already inside your house, maybe just in the hallway, and this flaw is like finding a key to the master bedroom. It lets them get deeper access and do more damage. Both are definitely bad, but yeah, the one that opens the front door is obviously the bigger, more immediate threat. Okay, so we've got names for these flaws and a way to score how dangerous they are. But where does all this information actually live? I mean, who are the watchdogs keeping track of this gigantic global library of digital threats? Well, it's not just one group. It's a whole ecosystem of organizations all working together. You've got the CVE program, which we talked about. They're the ones handing out the unique ID numbers. And then you have these big central libraries and government agencies that take all that data, analyze it, and help everyone figure out what's important. And one of the most important players here is the National Vulnerability Database, or NVD. It's run by the US government, and you can think of it as the public library for all of this stuff. It holds all the details on, get this, over 319,000 different vulnerabilities. It's a go-to resource for security pros all over the world. But even inside that massive library, some books are, let's say, on fire. They're way more urgent than others. And that's where an agency called CISA comes in. They maintain something called the KEV catalog. And honestly, the best way to think of it is as the FBI's most wanted list, but for software flaws. If a bug makes it onto this list, it means CISA has confirmed that hackers are actively using it in the wild to attack people right now. And this brings us full circle, right back to the beginning. Remember that number, 107? The flaws in that single Android update? Well, it turns out 2 of those flaws were on CISA's most wanted list. Think about what that means. It was a live race against the clock. Hackers were out there, actively using these flaws to break into phones, while Google's engineers were scrambling to get a patch built and pushed out to protect millions of people. So, after all that, what's the big takeaway for you? What's your part to play in this massive, complicated system that's kind of like a global immune system for our digital world? It's actually way simpler than you might think. That entire global effort we just walked through, the researchers, the CVE numbers, the CVSS scores, the giant databases, CISA's most wanted list, all of that, it all culminates in one single, simple thing. That little update notification that pops up on your screen. Your job is to finish the race. You're the last leg of the relay. The simplest thing you can do is turn on automatic updates. Just set it and forget it. But if you see a manual prompt, please don't just swipe it away. Hit that install button. You are literally the final link in a global chain of defense. That notification isn't an annoyance. It's a shield being hand-delivered to you just in the nick of time. So next time you see that update available message, maybe just for a second, think about the invisible army of people around the world that made it happen. And then just try to imagine the absolute chaos we'd be living in if that entire hidden system simply didn't exist.